Hi, everyone. My name is Michal Davidson. I'm going to be speaking today about security domains and why we need them. So I'm going to start with a little bit about myself. I'm a software architect at Dell Technology, where I lead the public cloud deployment and security for PowerFlex, which is our software-defined storage product. Now, I came to security originally more than 16 years ago without any kind of security background. That's something I want to speak about in this talk. And since I discovered that I love security, and I worked as a software architect, a security architect in a number of different companies. I also was an academic lecturer for courses in cybersecurity and in the software development lifecycle. And one thing I discovered along the way was that my passion is really to increase diversity in the tech field, and in particular in cybersecurity. And I started to think, why aren't there enough women in the cybersecurity space, at least not as many as I'd like to see there. And when you look at the numbers, you are seeing less women entering cybersecurity than even tech in general. And that's one of my motivations for thinking about security domains, which we're going to talk about today. So my first realization is that I think everyone is influenced by what we're seeing on TV or on movies, where you're seeing this teenager, this kid like 13 in a basement, tapping away on a keyboard for like 1 minute, 2 minutes top, and then oops, they're in, right? They've cracked. It doesn't matter if it's the CSA or the FBI databases or a bank or the mafia, but 1-2 minutes and they're in the system. And then you could feel imposter syndrome. Like even I today, I'm like seeing something like that. And I'm like, hold on 1 second. Like, I can't do that. What am I doing here? How can I say I know anything about security? And that made me realize that we need to stop thinking about security as this blob of security and rather break it into domains. And that's my first motivation here for speaking about security domains, really to increase diversity in the field by showing there's so many different career tracks within security, so many different realms and domains, and so many of us have a lot that we can contribute to the space, and really to encourage more people to enter the security space, even if they weren't hacking into a bank when they were 13 years old. The second reason I'm speaking about security domains is because when you look at computers in general, we've come a long way since seeing computers as a blob. If someone comes along and says, I'm an expert in computers, that's going to sound strange to us, because nowadays we have networking, operating systems, hardware, software, storage. And there's so much different expertise being developed in those different fields, different communities popping up. And even within software, if you think about it, you nowadays have full stack, front end, back end, conferences and communities focused on different languages. And I think it's time that as a cybersecurity industry, we're mature enough to understand the general security community is amazing, but we also need to start thinking how we can encourage people to develop specific expertise in specific domain. It could also help those of you looking for talent to really focus in on what the expertise is that you're looking at, and create communities and knowledge sharing around those different domains. And the third reason is, I think we're all here because we care about security and we want to improve the security of our systems and of our products. Now, it's natural, it's human that when we come to a system and we're trying to improve its security, we're going to zoom in and focus usually on what we know the best or what we enjoy the most. Sometimes it's going to be what the customers are asking for or what our managers are asking for. And that's often going to be one or two aspects of security. Now, what could happen is you end up with a system that's amazing from one point of view. You have like great monitoring or you're compliant, but you're actually neglecting the other aspects of securing your system. So actually, in order to attain that more holistic security of your system, that end-to-end security, I think it's important to first break down the security into different domains, and then you can make sure that you've covered all these aspects of securing your system. So I've spoken a lot about the why. Let's talk now about the what. I took security and I broke it into these 6 domains. Now, you could come along and say, you want to break it up differently. You're proposing different domains. that's not just fine, that's great, because my goal here is to start this conversation about subcategories, about domains, and I'd love to refine this model. What I did here was I broke into 6 domains, and we're going to work through those together one by one, discussing this particular expertise, the particular challenges of each domain. And if we have enough time, we can then take that and apply that to the cloud, because I think what's useful is once you have this overview of security, when you come to a new field, relatively new field such as the cloud, you can make sure that also there you're covering all aspects of securing your system instead of focusing on one and neglecting another. I'm going to start with compliance, because there is a lot of focus in enterprises, in companies where our product is actually targeting another company, selling to another company, that they do need to meet these compliance standards. In particular, if your customers are federal suppliers, they're going to care a lot about what the US government has to say. FedRAMP, the executive order. There are also generic standards like the SOC and ISO 27001. And there are also standards for particular industries like healthcare with HIPAA and PCI DSS for credit cards. What's interesting with all of these standards is they are third-party standards that you need to meet. There's always going to be a large aspect there that's not technical. You're actually going to see accreditors. I was actually surprised to see that chartered private accountants, CPAs, are accreditors for the SOC standard, for instance, because there's a lot of process involved there. It's not just about the tech stack, it's also about the people and the processes. Now, compliance is definitely important in order to achieve that goal of selling to your customers, but I want you to understand that compliance is not going to guarantee security. Now, compliance did something very challenging. They mapped out security requirements for a wide array of systems, and that's actually incredible. But on the other hand, because they're trying to do something generic, no generic cookie cutter template is going to fully cover all the aspects of your bespoke custom system. And it's actually there in those gaps and those differences that you're often going to find vulnerabilities. So if you're achieving compliance, that's great. Please don't think that means your system is already secure. Moving on to network security, this is where there was a lot of focus in the, I would say, pre-zero trust and pre-cloud days, where we did have more reliance on physical data centers, on physical private networks, and there was a lot of focus on really keeping out unauthorized users. So the focus then was authenticating the who and authorizing the what. But even nowadays, with this move to zero trust, we're still looking at who you are, what you want to do, and why. I would say with zero trust, there's a lot more focus now on the why, on establishing the motivations, this dynamic trust level. It's constantly changing depending on how suspicious we think you are at that moment. But I'm still grouping that all together in that category of authentication and authorization. Now, what's interesting here is companies' systems may come and apply a very high level of network security. They may be using, for instance, TLS 1.3, and everything seems fine, and everything's configured fine. But when you actually go and look deeper, maybe they're not protecting their keys well, and they're leaving their system vulnerable. And that's why network security, again, is not going to be enough by itself. You may be sensing a theme here. And now moving on to monitoring. And what's very different with monitoring is, yes, monitoring products for detecting cyber threats are definitely security products. They're huge in the security space. But most professionals developing these monitoring products are not going to be cybersecurity professionals. They're actually, because usually, almost always nowadays, automation is not enough. It's impossible to statically define what's considered an anomaly, what's considered an attack. You first need to learn. You need to learn the valid behavior of your users, and then you can say, okay, this is different. And for that, we need a lot of expertise in data science and in machine learning. And you're going to see mostly that kind of expertise in this space, with some really cool collaboration, of course, going on between security experts and these data science experts. And that's why I wanted to call it out as a whole different domain. Now, when it comes to cryptography, that's what initially drew me to security. Like I said, I had no security background. I started off my career as a software developer. And then when I learned about cryptography, I was like, wow, this is so cool. We're taking maths, applied maths, and these few simple principles are actually securing the whole internet. And what I'd like to recommend is if you're in the cybersecurity space and you never happen to actually study cryptography, there's some really good resources available online. I'm going to link to them at the end. And if you just do some initial studying on cryptography, I'm not saying like go and do a full academic course on elliptic curves and the maths behind it, but just to understand symmetric cryptography, asymmetric cryptography, the difference between encryption and signing, the importance of protecting your keys, you're going to come out with a much better and much deeper understanding of the protocols you're probably using. And I think once you understand cryptography, you also understand the importance of protecting specific keys. So that's why I called out here the topic of key protection, where ideally, along with protecting your keys, you're going to be protecting the cryptography and the code using those keys in order to improve the security of your system. Now, I separated here embedded security, that's really a subdomain, because ideally, definitely I would say in the pre-cloud space, we did try and use embedded security wherever possible, or hardware-based security. Now with the executive order, there's a lot of focus also on secure boot, because there's more understanding that we need to protect the whole chain of our software, starting from the hardware and the firmware up to the software we're using, in order to make sure there wasn't some kind of vulnerability planted there previously. The idea of trusted execution environments or security enclaves is also a lot of focus on in the chip space. It doesn't matter if it's for modern PCs or mobile devices, where we are trying to create a secure area, because there is a lot more usage of bring your own device and this the non-secure usage going on, living alongside the secure usage in unmanaged devices. So this brings me to security architecture. Now, in security architecture, we're mainly hearing about security review, or mainly thinking about security review. My message when it comes to security review is, if you are performing some kind of security review on your process, and I really hope you are, please try and move that to as early as possible. Because let's face it, you could be spending the same amount of effort on a security review, but if you're doing it at the end of the process, it's very unlikely that you're going to want to postpone a release because of any kind of security vulnerability discovered. So you're going to get so much added value by doing that earlier, because it's not really about what the vulnerabilities are that you identify, it's really about what you do with them. So by moving that process earlier, you're going to accomplish a lot more. Something else I wanted to mention is there's also a security architecture where you're architecting brand new products. And that's really cool. And what you do there is you're taking the building blocks we mentioned previously, the network security, the cryptography, the protocols, and you're creating something new. And that's something we do try and do within security always, is reuse what we have done, spin your own crypto, in order to accomplish something that's more secure and has already been tested without introducing new flaws. So I hope by now that I've convinced all of you that there's a lot you can do within security and a lot you can accomplish without being a hacker. Now, when it comes to hacking, I actually did feel like, okay, I want to understand more. And I did learn a bit about this. And what really struck me was the amount of patience that's required in order to do reverse engineering. I kind of like to compare it to, if any of you have seen Sherlock, there's this scene where he gets a sack of shredded paper and he painstakingly puts these shreds together to find the message. Now, when you're watching that, you're going to see 1 minute him taking out the sack of paper, and then fast forward a week, you see the coffee cups everywhere, and he's accomplished it. But in practice, he's been sitting over this for a week. And I think it's very similar to in reverse engineering, that you may be seeing in this TV show 1, 2, 3, and you're in the system, but that's not what's happening. And I think that's also something that can help us with imposter syndrome, because hacking is something that does require a lot of time and patience along with skill. And if you're seeing someone who's hacking into the system in a few minutes, it's usually because they're using some kind of tool that someone else developed for them. So that's something that I wanted to mention here. So to summarize, now that we've looked at security domains and we've split it up, we can take this model and see how we apply it to the cloud. So in the cloud, there are a lot of different security challenges. I'm not going to list them. We've heard a lot about that already today, and it's really interesting. I'm just going to speak about specific challenges and how that changes those domains. So we're going to quickly walk through this. In terms of compliance, the same compliance you need on-prem, you often need on the cloud. But on the cloud, it may be more time consuming. It may be new for the people, the accreditors giving that compliance to. You should take that into account. There are specific standards for the cloud like ISO 2717. In terms of GDPR, something I've come across a lot is that in terms of privacy, there's often this limitation that you shouldn't be moving your users' data from one region to another. So you should be really be thinking about that if you're deploying a multi-region cloud system. In terms of network security, what's interesting is while the terminology is really changing, and you're often going to see a different terminology for every cloud vendor, for instance, security groups, when you dive into it, you see that they're trying to accomplish the same things. And it's very similar to compare this virtual networking to the networking on-prem. You're still talking here about who you are, what you want to do, and why. And once we're able to map that into something more generic, we're able to understand how to protect our cloud in terms of the network, the virtual network, the same way we were on-prem. In terms of monitoring, now this is something that I find fascinating. There's so many tools now in the cloud space, both native cloud vendor tools and third-party tools. And it can get overwhelming. But I think what's interesting is when you look at the tools, a lot of them fit into this monitoring space, which does make sense because when you think about the scale of the cloud and you think about the speed of its change, you definitely need some kind of automation here and some kind of monitoring. But once we do this breakdown and we see that many of these cloud tools are monitoring tools, we're able to understand, okay, what are we achieving with these tools? We're achieving this and this and this, but we still need to think about the network security, or we still need to think about the cryptography. And that allows us that more complete end-to-end view of the security of our system. When it comes to cryptography, obviously the math hasn't changed, but the unique challenges of the cloud are we're less able to rely on the hardware. I mean, intentionally, we're trying to have this disconnect here between the hardware and the software. So first of all, definitely protecting keys is a challenge. There are hardware security modules, HSMs on the cloud. I think that they are expensive. Typically, customers only want to use them when they have some kind of compliance requirement. Usually, we try and use software solutions, some kind of key management store, but we need to spend a lot of effort thinking how we protect these keys on the cloud when we can no longer rely on hardware security. Another challenge I'm seeing a lot is around identity, because often an identity, a unique identity, is tied in at some level to the hardware identity. It doesn't have to be a secret identity, but at least it's something unique that can't be cloned. And then when you come to the cloud and you intentionally have this disconnect, how do you ensure unique identity on the cloud? How do you prevent cloning on the cloud, which is relevant to many different industries? And there we still have some challenges. In terms of security architecture, something interesting is that if you look at each cloud vendor's well-architected framework, they are very focused on security, and there is a lot we can learn there. I do think we have still a lot of challenges ahead in terms of the multi-cloud, because every cloud vendor, I would say intentionally, is very cloud specific. And that idea of how we have universal paradigms to talk about the cloud, to talk about securing our cloud, so that we can have this more holistic end-to-end solution for the multi-cloud. I think that's something that still has work to do, which is actually exciting, I would say. So that's it in terms of the cloud. I'd love to continue this conversation. We could speak on chat, on email, LinkedIn. I wrote a bit more about cloud security domains, and other security topics on Medium, Miss Architect. I'd love it if we also continue the conversation there. And thank you. Oh, and in terms of resources, I'll send them out afterwards, but here's some resources for all the different domains.